Let's get started. Last time we did map and fold. So today we start with something new. It's called data types. So you can create your own data types. So if you still remember, we say let t is equal to 1, 2, 3, 4. That is going to be an int list. Right, this is an int list, but what if I want to put different types in the same list? I want to do 1 and 1.5 and then possibly hello, right? I want to do that. And today we look at that, okay? I said last 3 row, we don't sit there. Can you move everybody? Every time, I remind you and you don't care. Last 3 rows. Yes, last 3 rows. We have a lot of seats here. Please sit here in the first row so that I can see you. Yeah. We're just wasting everybody's time. Cool. This is what we're going to do, right? Just say I want to put different types in the list. I want to do that. That's for today. So that is data types. Cool. So we have something called type, right? You can create a type of gen. So it said, I want to define a new type called gen. This gen, this is called constructor. It starts with the uppercase. It can be an integer of int, or it could be a float of type float. Or it could even be a string of string. Cool. If I do that, I just created a new type gen. I can load it. Use data to .ml. See, I created a type of gen. This type gen, right, it could be integer, it could be float, it could be string, how we use that. So let's see. If I type int 10, remember I said I could have a constructor with a type of 10 that carries data. Then you see it is, it's a gen type. Remember you have int type, you have, float type. Now suddenly I have gen type. See, I have gen type. That also I can say float of 1.5. That's also gen type. Okay, that's also gen type. Now you see, okay, if all of them are gen type, why don't I put them in the same list? That is possible. Let t is a list. That list can have int of 10, a float of 1.5, and str of hello. Right? This is possible now. Now, if I load it, see the type here? That type is gen list. Is this cool? Right? It's a gen list because they all have the same type. Int 10, float, right, string. They all have the same type of gen. So now I can, what is this ding thing? Can anybody fix that? Output build internal speakers HDMI I don't know. Okay, anyway, cool. So that's the gen type. Now what if you want to print that, right? Then you have to match, right? The gen type is a generic type. For example, it's not int, it's not float, it's just gen type. So if I say let print gen, if you give me an x, how do I print it? That is, I'm going to match x with, it could be int of I, then I will print it as an integer. Print int I. If it is a float of f, then I will print it as a float f. If it's a string, then it will be an str of s, then I'll print it as s. That's it. That's how I print. So how do I print the very first item? Then that'll be, let me load this, and then I say print, here, print gen, list.ht will give me the head of the list. I'll take it from the T. Cool. So that is, T was the very first item is int 10. Cool. I get int 10. And then it matches this case, int I. Then I'll just print 10, right? If that matches the case int 10, I will print 10. Yes, it did. It printed 10, right? It printed 10. So what if, let's say, print the gen list. How do I print the entire list? You just learned that in last class. That is list.map. And I will say print gen and T. That's it. Because T is a list. If print gen can print 1, I want to print everything. That's just map it, right? Map it. That is list.map. I'm going to apply this print gen to every member of the list T. It's printed here. It printed 10 very first time, and then it printed 1.5 second time. That's this float, 1.5. And then after that, it printed hello. Okay, so with this, now you see, I can create my type. So I can create another type. Let's say shape. Shape can be a circle of float. It takes like a radius, right? Or this shape could be a rectangle. That rectangle of its width and the height, that's two floats. Float and a float. That's it. So my shape, right, it could be a circle, I said. Or it could be, I save it, and I'm going to load it. Yeah, I have a shape type. See, this is a shape type. I just created a new shape type. Now if I say, see, I create a list of rectangle. Let me create that. Let lst is equal to rectangle. You have 1.0, 2.0. That's a rectangle. And I also have a circle. This circle has 1.0. It's easy. And then I have another rectangle that is 10 and 10.0, 20.0. Cool. See, I have a list. Let's load it. 46. What did I do? Yes. Cool. Look at that. I just have a list of shape list. See, the type, this is very cool, right? The type is shape list. That is very, very cool. Because I just have a new kind of type. It's called a shape. Now I put into a shape list. How about let's calculate the area of each item in a shape list. That is let area. You gave me a shape S. What do? I have to match it. That is match S with. If it's matched to a rectangle, right? Rectangle has height and width. That's easy. I'll just multiply height, multiply width. If you give me a circle of radius, then it'll be 3.14, 1526 multiply dot r multiply r. That's it. See? Now I can calculate an area. So let's calculate the area in the list. This list has a shape list. I want to calculate the area of each item. That is list.map area of LST. Come on, why do you do that to me? I have that area. See, isn't it cool? It calculated every area in the list. That is this. See, that I map area. The map function give me one item from the list. That will be very first rectangle. That area is 1 multiplied 2. That is 2. And it gives me, next time it gives me circle. My area, it's magic, right? If you give me circle, I do circle, and then that is 3.14. And next time you give me a rectangle, I'll calculate 200. So this thing now, what we did so far, it is, if imagine you have a shape interface in Java, and then it has a method called, abstract method. How about that? Has an abstract method area. We just did that. So anything that implements a shape interface, they have to implement the area. And then when I call area, polymorphism works so that when I call area with rectangle, it calculates area for rectangle. When I call circle, it calculates for the circle. We just did the exact same thing. See, this is the area function that takes this generic type. This thing is also called abstract data types. So the syntax is type and then a name, right? The coin. We have an example on the slide. And then you have head and the tail. So it doesn't have to carry data. This is like an enum in Java or C, the enumerator type. It doesn't have data. It's just itself. Fine. If you say load it, look at that. What happens? If I say head, it said, oh, this is a coin type. Isn't it cool? I just created a type called a coin. When I say head, it's a coin type. When I say tail, that's also a coin type. When I create a list of coins, that's let C is equal to head, tail, head. Cool. Now I have a list of coins. See, it's a coin list. This last thing is a coin list. So let me just copy that. See, it's a coin list. So now you can walk through, count how many heads there, right? Let recursive sum. It takes an X, and then it says match X with, if that matches to head. Come on. And then some tail, then I say 1 plus sum of tail. If that matches to a tail, that's the item when you tick it. And then some tail, so sorry for the confusion. This tail is that, like when I took it, it's a head or tail. This T is just a tail of that list. Then you just return sum of T itself. That's it. So now let's load it. Not exhaustive. What is that? I match the head. I match the tail. Empty? Okay. Why did I forget that? If it's empty, 0. Very cool. Now it's not exhaustive. That's the sum of my coin list. What is that? C. How many heads there? 3 heads. That's correct. I have 3 heads, 1 tail. Okay? So now you see you can create any kind of type and then you process it with pattern matching. I'll take a question. Yes? Yes. But my answer is yes. I didn't understand the question though, but yes. If that's not the answer, please come to me after the class. Yeah, I guess it like you can't have 2 heads. It has to be different, something like that. Hello. It's mine.
So
Yes.
an abstract data type, you said?
Yes, the coin, the type coin is an abstract data type. It was not there, and we just created one. See? I can create a list of a tail. What's the type of this thing? It's a coin type. Yep, it's a coin list. I just coined it.
So is it sort of like enum or like?
Yeah, you can think of, it's like, user-defined data type.
Cool. And the last one, the gen, is that just?
Yeah, same thing, like coin. I coined this, I generated that.
No, but the coin can only receive either head value?
Yes, it can only be enum type. It has be head on tail, nothing else.
And the gen type, that's just?
It'll be int, float, or a string.
Right.
No computer. Yes. Tell him no computer there. No laptops. Yes, I know. No surfaces. Yeah.
Can you scroll up a little bit?
Scroll up. Okay. It's better than can you go back? That's okay. Where do I?
No, that was fine. I didn't want to see the type.
Oh, you want to see the type. Okay. Yes.
For the gen type we made, can we add integers to it without saying this is int?
No, you can't. Integer is int, the type. Anything in a gen has to be gen type. That's int of something, float of something, or str of something, or something that doesn't carry data. You can add it. Yes?
If I made a type that took either a true or false, can I use that new type in an if statement?
Instead of Boolean, right? Yeah. The coin works like Boolean. You say head is true, tail is false. You can replace entire Boolean, right? That coin, for the future, that's your Boolean type. Yes. Yeah, pencil. Then it will shadow it. If you create a type as head and tail, you create another coin. Head and tail, it will shadow the one that you created before. Cool. So now, with this type, we can do cool things. Like, for example, I can create a linked list. Linked list. Cool. Let's create a linked list. That is a type. My list is linked list has null node. That's nothing at the very at the end. That's nil or null. Or I have a node. That node carries data. Node carries data that is, it carries an integer. So this imagines an int list. If this is any kind of list, you say tick A. It carries integer and then my list. So my tail is going to be my list. No. I can't say node. I can say const. Usually that's what we do for the list. When we say node, it'll become a tree. That's it. So this is my construct for list. So look at that. Nil. It's a list. It's an empty list. There's nothing in it. What if I have something in it? That is const 10 and a nil. That is, now I have this one node, right? Or, the const. It has 10. After that, it is null. What if you have multiple nodes? That is, cool, I can use this in another const. That is const of 20 and then this thing. So that is now, look at that. It's 10. I can bind it. Say let t is this. So now you look at that case there. I'm going to show you. So this thing here, I have a node that's imagine, right? You have 20, and then next I have 10. Next is null, right? That's it. I just created something like that. So let's copy it and calculate the sum. So I have this let t. Now let me write the sum. That is, this is sum for sum of the list. Let recursive sum. If you give me a list lst, and I say match lst with, And then if it's empty list, wow, return 0. If it's not empty list, then it'll be head and tail. What happens? I will take, that's not the case. It'll be a cons, right? It'll be cons and then AB. So because this is a construct, right? When you match it, it'll be nil, right? It'll be nil or cons of something. If it's cons of something, I'll say A plus sum of B. Because remember, I take the number, that's a linked list, the value in this node, and this is my tail. So I have to do exact same thing for my tail. So I call sum B, and then let's save it. Let's make it even bigger. That is cons of 30 with entire the thing. Cool. Now let's load it. Huh? Ah, that's nil. Very cool. Thank you. Yes, nil. My list. It's nil or cons, right? It's something like this. It's something like this. There's no that paren list thing. Call. Now load it. Yes, everything worked. So let's call sum of t. That is 60. Look at that. That is correct. Because in our this my list, it has 3 items. That is 30, 20, 10. Yeah, I'll just add them all together, right? So now look at that. For the next project P2B, we have a binary tree. I'll show you binary tree. That is binary tree is defined. Type tree is, it could be an empty node. That I call it empty. You can call it nil if you want. And then otherwise, I have a node. That node can have a tree, left tree, and then the value is integer, and then my right tree. That's it. This is a binary tree. If you load it, see, it worked. So my tree. Let's create a tree, empty. Oh, this is an empty tree. How about a real tree? So my left child is empty. Our value is 10. Right child is empty. Oh, that's a tree. See? It's a tree with one single node. Yeah. This is an empty node with one single node. So let's create a real tree. Let t is equal to a node, and my left is empty. Root is 10. My right is another node. That node, the left is going to be empty. How about that? And the value of that, the right child is 20. Right of right is empty. Yeah, I just had a very simple tree. Yeah, I have that tree. Look at that. This T is a tree. I'll show you how that tree looks like. That tree, it has a root of 10 and a right child of 20. And that's it. Okay? That's it. I'm writing on this thing. I can't see it. That's why it's ugly. Okay? That's not my handwriting. But otherwise, that's a tree. So everything else is empty. Is that cool? I'll take another question on the data types, and then I'll finish up. Yes?
You can use any word for the empty, right? You choose.
Yes. Anything with uppercase. It could be nil. It could be your name. I just made it up. Yeah? Nah. The nil is something that you came up with. It's just something that uppercase that represents the state where the tree is empty. Unit is a type that void. Remember C like void. That's our unit. You can't do that. Yeah. Now I created a new type. So if your type matches, and the compiler says, "Oh, okay, this is the type you created." Not because of off. When you say type and then gen, it's an int. Then when you give int 10, and then it matches to that type. Just like if you say 10, compiler says, oh, 10 is an integer, so it says the type is int. When you say head, it says, oh, it's a coin type. Yeah?
Can a user-defined type contain another user-defined type, like Jen could have a coin in it?
Yes. Yes, it could be nested. Where? Which line? The last thing? Yeah, type. So that's my left. It's a recursive data structure, isn't it? Tree. My left child is the same kind of tree, so it's the same type. My type is tree. My left child is a tree too. Every node has a left child and right child, but my left child could be empty, right? Yeah.
If you wanted to access the value, let's say the right and left trees like aren't empty, how would you access the value?
Just like my list, like you match.
Okay.
Yes, let's do that. Make Shruti happy. That is, let sum. Well, I like the sum so much, huh? I already created 3 of them. Let sum. If you give me a tree, match T with, if it's an empty tree, I go 0. If it's not empty tree, then it'll be node, left tree, a value, and the right tree. Then it'll be, the sum is going to be value plus sum of left plus sum of right. Is that correct? So this is a recursive sum of the tree. So now I load it. Now let's say sum t. What will be it? That is 30. Because in this tree I only have 2 nodes, 10 and 20. But that tree could be a huge tree. It still calculates a sum. I just match a node, get the left child, the right child, process it recursively. Okay, so yeah, let me create one. Type int option, right? So int option type is equal to, I say, hey, your type is none or sum of int. With this, I just created an int option. If you have a function that returns integer, sometimes it doesn't return anything, now you can use this type. That is, look at that. If I say none, that is int option type, or sum10. That's also int type. Why this is cool? Look at that. Now I can re-implement my list head function. The original implementation is like this. Head of list. Originally we implemented let hd lst is equal to match lst with empty list, empty list. If it's not, if it's head and tail, I could not do h. I wanted to get ahead. If I do that, because this is a list, this is a single item from the list, it doesn't type check. And we put this as an ugly case like this. Right? That's what we did. If I show you that, what will happen? Error will show up. Oh, what did I do? I didn't type this. It showed up. There's something wrong with the OCaml. Cool. See? So now head of the empty list, empty list. Because head returns a list, when I say 352, it's still, I know, my finger doesn't listen to me. Okay, so when I say 254, and then it gives me the 2 as a list, because I have no choice. I have to return a list. Now I can do better. This is a better head. Okay. Head of the list, okay? When you watch the video, don't be confused. Better head. Cool? I didn't know. I know. Is that okay? Then I'll cut whatever I said. If you ever watch a video, I cut stuff. So I'm going to. Cool. Now the better head. If it's an empty list, I return none. If you have some value, then I return some. Isn't it better? Cool. Now, look at that, my head now. Head of the empty list, nothing, none. It returns none. It doesn't return a list, none. There's nothing in the, there's no head. If you give me a 2, 5, 4, now it gives me some too, right? That is great. Now I can handle. It doesn't give me, just empty list and there's some list with a head. No, this is a better version. So now, if I improve this int option, go back to his question. His question asked, what if I want to use a generic type? That is, type tick A option is equal to, if it's none or sum of tick A. Then this is a generic type. So now I can use this for any type, right? Any type. That is, if I, come on, I move it to before the head function so that my head works better this time. Go. Now if I load it, cool. Now look at the head function. Head, empty list, it's a tick, it's none. There's nothing in it. How about head of 1? It's sum 1. How about head of A? That's sum A, right? Isn't it cool? This option type is so cool. Other languages like Java is adding, Java has option type so that when you call a function, if you return null, that's very bad. If anybody use that return value, null pointer exception, right? It's so many applications, they throw null pointer exception because the programming think there is something and then call the method on the null, right? So instead of returning null, now you can return option so that even it's null, it's still something. It's a none, right? So this is our option type. So Java, look at that. I exit, I OCaml again, and then say option. I say none. Come on. It's tick A option. This thing is built in. So OCaml has this type. So now you can use a none type or sum for all the things that it may not return what you wanted. Okay? That concludes my, no, that doesn't conclude. Yes? It's optional. Yes. Okay. It's not called option. It's called optional. Thank you. It's called optional in Java. It's called option in OCaml. Java is always verbose. Like optional. There is 2 more, right? We say option. It's better. But I tell you my story. Option is not good in real life. Choices. I just digress. Give me 1 minute so that I can say stuff I want to say. Choices are not good. Which one do you want? Make it simple. Just make it like no choice. Get this one. So that concludes my data type. Any question? Yes? One more.
Is it possible to have a function that some assuming that all these were int lists? Is it possible to sum the head of all the int lists or no?
Sum and none to the int list?
Sum all the heads of the int list. So if we have like two int lists, take the head of this one. No, because
look at that. Let's just write that. That's a sum head. Right? Sum head, let's just say you give me 2 lists. Is that what you want to do or no? What do you want to do? Yes, you can. So
even though it says sum, like SOME, you can still add them together
SOME.
as lists? Yes.
SOME, nothing. It's just a construct. It has no meaning whatsoever. It's just the option type. I say sum, it carries some kind of data. I don't care. Right? So that I know it's returning something. I'm sorry. I thought you want to add 2 lists. Okay? But if you want to process multiple lists, there is a function called map2. Map2 is a better version of map. It can handle multiple lists. Apply one function to 2 lists. So like I have 1 list and another list. I want to add each item together. That will be map2. I don't know what map3 is. Cool. This class is fun. You guys paid more tuition maybe. I don't know. But there are more questions. You're more fun. Yeah. Yes, that will be project 2B. If I do that, I'm going to do your work, right? That project to be, P2B, that's a generic tree. Instead of int list, it's a tree. Just change that, wherever the place I created that tree, the int to tick A. That will become a generic tree so that the node can have a string value, any value you want. One more.
So tick A and option are both keywords in OCaml, right?
Say that again?
The tick A
Uh-huh.
is a keyword.
Tick A is an OCaml keyword. Option is not. Option is just, I created a new type called option.
Oh, that's the name of the type?
Yeah.
There's also like string option and stuff like that.
Yeah, anything like that. I created it. When I say type, yeah. When I say type, look at that. When I say type tick A option, what color is that? Green or blue? I'm colorblind. Okay, green. That option, I created that. You can call it with your name.
Oh, okay. So option is not a keyword.
Option is not good.
Optional in Java was confused.
Yes. Yes. So when I say tick A option, the option is like any type. When I say int option, the sum can only carry integer. This sum can carry any kind of data because it's a sum of tick A, right? That's the difference. So I start with the int, simple one, and I change to tick A. Now get your clickers. So let's do quiz. Okay. So we learned basic types, list whatsoever, right? Records, tuples, functions. Today we want to see a new type. So this is the part that I read the slides. So this is a new type. I created a my type. It's an int and an int list, right? It's a tuple, so it's 3 and int list. That's my type. Now you can create your type. That's as a coin. You just coin the type, head and tails. So this is a flip function. If you give me head, I'll make it tail. If you give me tail, I'll make it head. This is that count function, how many heads you have. It's the exact same thing I created. It's like enum type in C, so it's yes. And then this is all that, explanation, how you create. It's a type, name. It's called constructor. It starts with a capital letter. And then it carries a value. It doesn't have to carry a value. This is that shape type. It's a shape can be rectangle and circle. Now I can put them into a list and call it with the area. It automatic, right? If I give a rectangle, it'll call, it calculates area for rectangle. If I give a circle, it calculates for a circle. This is, it's called algebraic data types. And this, I can put them into a list. That list, what is the type of the list? That is shape list, right? We did all that. This is the Java version of that. See, if you want to do that, you create a shape interface, and then a rectangle implements that shape. Now you have to implement this area function. If circle implements shape, you also have to implement area function. Now you call this area with a circle object. This is called, if you call it as a rectangle object, that's called polymorphism. Okay, this is an option type. So with that, now you can do things like this. If you divide, if it's y is 0, it's divided by 0 error. I don't want to do that. With that, I return none. If it's non-zero, then I will calculate. I'll return with sum. Okay. That's option type. This is a real polymorphic option, right? This tick A option is sum, tick A, or none. So you can apply this for all those types. Anything that, like the head function, the tail function of a list, if it could return nothing, then you can return an option type. Oh yeah, see? Like it's optional in Java. Optional is something new. A lot of students, they don't see that. It's optional. That's why they don't see that. I'm sorry. I try to be funny and sometimes no. Yeah, it's optional in Java, so a lot of people don't see that, okay? Cool. This is that all the example. You're using this option type. Okay, go. 5, 4, 3, 2, 1. Okay. %. That's very good. So let's see. That is correct, 92%. Very first one, the type is what? Int. Well, come on. Int star, and then S star, string star, string star. And then this entire thing is a list. If someone is watching the video, I mean, this is not my handwriting. This thing is ugly. But what can I do? Cool. The second one is correct. And then the third one, where's... Okay, the third one, this is the int, that's int, that's a 5, and then star. This is S star S star S list. It's inside is an S star S list, and then again it's a list, right? So get that. This is an int star int list, and then you put together int star. A string star list, and that's another list outside. That is wrong. And then the very last one, this is int S star S list. How is that different from the other one?
Yeah, see, it doesn't work. There's no parentheses of tuple.
No, you don't need that. You're wrong. Look at that. 1, 2, 3, you don't need that paren. It's just an int star tuple. You don't need that paren. You're one of the 8%? I'm sorry. So the very last one is int, and then you have a list. Same thing then. It's just added a paren. So that B is correct. Go. 5, 4, you don't trust yourself. Okay. Very cool. So if you give me a float int, that it said if it's int, do this. So this matches this case. Float int. I'll take this 2. I'll make a float. I is 3.0. This is 2.0 now. So that is 5. So 100% people are correct. That's very good. Another thing here, look at that. There's another case is missing. That is int float. So when you run this code, it'll give you a warning, say one case is missing. And if you, look at that. If you reverse this order, it'll throw an exception because it cannot handle float. Int comes first and float comes second because one case is missing. But in this case, we didn't give that, so it will work, okay? See, if this is int, okay, and then a float. So when you match, this is a tuple, and all of them are tuple, you have to match one of these cases. So if the tuple has 2 items, there are 4 different cases. So you have int, float, int, and int float. Based on that, if you give me 2 float, I don't have to convert. If you give me 2 int, I'll just return int. But if 1 float, 1 int, I have to convert one of them. So it's possible that you can write int and then keep this as j as an int and convert this to int and remove this dot. That's also fine. You have to return float or int because that's the type. The num is int or float type. You have to return one of them. Hopefully that answered your question. Question for the quiz. Okay, yes.
So could if we define num as type num equals int type float instead of int?
Num, if we define it as what? Say that again.
Just int type float.
You can't do that. It has to have a construct. If you say just int with the uppercase int, it doesn't carry data. Lowercase, you can't. The construct has to be uppercase. You cannot. That uppercase int can be anything. It doesn't have to be int. It could be ant. As long as it starts with an uppercase, it's just a construct you made up. It must start with uppercase, but it could be anything. Ah, I can't stop this class. Yes? No, you can't, because you have to return same type.
Yeah, so if you changed
All of them to int, yes. And then you could just return like integer number. Yeah, you can do that. That is, we will see that in the future. Yes. I'll upload an example. She asked, okay, very good question. So do I have to return all these crazy, ugly stuff? This. No. As long as all these return type, if they all return like an integer, fine. We do that. When we evaluate an expression like int 10 plus int 20, then at the end you can return just 30 instead of doing that int thing, if you know the type is integer. But in this case, if you do that, you cannot return float, because then it's a different type. Well, you guys are good, just keeping me slow. Go. 5, 4, 3, 2, 1. Cool. It said, if you take f as an argument, this f should match this thing, because remember, they all have the same type. If this is some n, that's option type, and you cannot give me float type, right? If you give me float, it's error. It doesn't type check, right? That is our case of answer D. But never in my life I had this bad a quiz, so what I'm going to do, I just delete that last question and then revote. Vote now, come on. 5, 4, 3, 2, 1. I stop. See? This is how I teach. This is that list I already created. We run the example. This is the syntax, how you do it. Now this is the last topic. This is exception. It's exactly the same as Java. Java calls it try catch. We say try with. With is all that match cases. We have to catch one of them and gracefully handle it. That's how the try catch works. Exception, right? This is try with. Please read it. You can create your own exception. You can fail with. It raises an exception. For example, if y is 0, I'm going to throw an exception, say divide by 0. Otherwise, I will divide it. Hash map. Associative list. When you look up a key, if it exists, it returns that value. If the key doesn't exist, it will throw an exception called not found. So anytime you use hash map, associative list, you have to handle that case not found. Because otherwise, if you look up, your program will crash if the key doesn't exist. That would be the first 10 minutes lecture for today. It took 1 hour. Now let's start the next one.